Alrighty, time for some nighttime coding. Alright, XOR, exclusive OR after range multiplication queries part 2. Part 1 I think was yesterday. Hard. Eeks. You're given an integer array nums of length n and a 2D integer array queries of size q where queries at I is left, right, k, and b. For each query you must apply the following operations in order. Index equals left, while index is less than or equal to right. Update nums at index equals nums at index times b mod 10 to the 9th plus 7. Okay, so this is exactly the same as yesterday, but the constraints are bigger. Constraints are bigger, and I assume it cannot be n squared. Okay, so let me go ahead and pull up yesterday's deal and see just how poorly it runs. So yesterday I did think about the possibility that there was a faster way than n squared that I came up with. I was hoping it was adequate for like a hard version maybe. Actually a hard version kind of slipped my mind, but I was hoping it was going to be enough. But obviously n squared is probably not going to be good. But this is yesterday's version of the solution where for each query I do a for loop that does that query. So it's pretty straightforward in terms of just raw implementation without any real optimizations. We'll see how poorly it times out, I assume. Because yesterday it was 10 to the third is kind of the outer and inner loop, so it's 10 to the third times 10 to the third was 10 to the 6, which is like 100,000. Or no, 10 to the 6 is 100,000. No, 10 to the 6 is a million. Here it's 10 to the 5th times 10 to the 5th, so that'd be 10 billion. Alright, so let's go ahead and try to figure out what to do to optimize here. So I was actually pondering this, like, is there any property of factors influencing or simplifying the XOR? Like if I factored the values that are being XORed in some manner, can I simplify knowing that factorization? Simplify the calculation of the exclusive OR of those values. So like 2 times A or A XOR B versus 2A XOR 2B or 3A XOR 3B. Do XOR, well, if it was a product of, if there were 2's in the multiplication, I wonder if they can somehow cancel out. So I think example 2, so you're multiplying by 3 here, multiplying by 2 here, multiplying by 3 to 1, 4, skipping 2, so 3 and 5, right? So that becomes 9 and 15. 1, 4, 2, 3. Exclusive or properties. Like I just know the main ones. It's like A exclusive OR with 0 is A. That's kind of like the Danny property. A exclusive OR with A equals 0. That's kind of like negation property. What other properties are there? I guess I really need to know like 3A XOR like 3B, how that differs than A XOR B. If there is any sort of connection there. I guess I'll just test an example, some values to see what comes up. So what values to test here? Maybe 1 XOR 1 XOR 7. No, XOR 6, right? 1 XOR 6 is going to be like 0, 0, 1 XOR with 1, 1, 0, which equals 1, 1, 1, which just equals 7. And then 3A, so let's say 3 times 1 is 3, so 0, 1, 1 XOR with 3 times 6 is 18. 18 will be 16. 0, 8s, 0, 4s, with 2 and a 0, 1. 16, 8, 4, 2, 1. That place value. So that's 5 digits. So that's going to become 1, 0, 0, 0, 1. One, 0, 0, 0, 1. Yeah, okay, let me do it. XOR calculator. I'm going to try something besides that first one. That first one is so horrible. It looks exactly the same as the first one. Holy shit, like, is there not a better calculator interface? Like, why is it so... Holy shit, guys. It's like they don't have any sort of... Why? Why is it like this? Give me a slick-looking XOR calculator. Wow. It's just so bad. What is going on? Okay. This looks simple enough. I want to test 1 XOR 6 to make sure that it's give me 7. Yeah, okay, 1 XOR 6 was 7. And then 3 XOR 18, right? 3 XOR 18 is 17. Yeah, so that's 17. 16, 0, 0 8s, 0 4s, 0 2s, and a 1. Is there a pattern there? One, 1, 1 versus 1, 0, 0, 0, 1. And 3 is, let's go ahead and just do 2A versus 2B. So that means it's going to be 2 XOR 2 XOR 6. gives me 4. So that would be like 4100. How is that at all? Is there any pattern there? 1 XOR. Oh wait, I'm doing it wrong. It's supposed to be 2 XOR 12. 2 times b is 2 times 6, which is 12. 14 is the answer there. Alright, this might as well just do a couple more. 4a XOR 4b, which is going to be 4 XOR 24. 28. So this was 14, was it? 14, which is going to give me like an 8, a 4, a 2, and a 0. 8 plus 4 is 12, plus 2 is 14. And this is going to be 16 plus 28 minus 16 is 12, so 8, 4, 0, 2, 0, 1s. Okay, I mean, I see the pattern there. And this, if I just use powers of 2, it just moves, it shifts over the value, right? It shifts over by 2. So 7, 14, 28. Let's go ahead and just do 6a versus 6b. Kind of what I expected, to be honest. Okay, so it'd be 6 XOR 36. 6 XOR 36 is 34. Okay, so 7, 14, 30, 28, wait, 34. Yeah, okay, yeah, so no. Six XOR 36 is 34. So 34 would be minus 16 is 20. No, minus 32 is 4. So 116, 132, 0, 16, 0, 8s, 4, 0, 2, 0, 1s. So I guess it needs to be a power of 2 that multiplies in order to kind of just move it up, right? So like 8a, 8b, this should be 8 XOR 48. So this should give me, in theory, 56, I want to say. Yeah, 56. So it's like 1, 1, 1, and then 3 zeros instead of 2 zeros, 1 0, and no zeros for the original. So if there is factors of 2, factors of 2 just shifts the value that you get, which makes sense. So in theory, you could factor the powers of 2 from certain products. Maybe. Maybe I'm just doing a wild goose chase right now. Maybe I'm just doing a wild goose chase. Oh. Maybe what I should be thinking of is somehow tracking the if I think of each index as a kind of a bucket, where the value is obviously in that bucket, and also I'm adding to that bucket the multiplier of the multiplier value of the query at those certain indices, so that somehow if I can see that there are, no, does that work? I don't think that works. It needs to be, yeah, that doesn't make sense. I was thinking somehow leveraging the property of XOR, that is A XOR A equals 0. But if I'm thinking about buckets, if I have like an M and a K here, it's not like if these two M and K multipliers into this product is going to cancel out. Or even if there's an MK in this thing as well. Well, this is going to be 0 because it's the same, but if this was MKA and MA, I don't think that becomes 0, right? Yeah, that doesn't become 0. It's like saying 6 XOR 3 is going to become 0. It's just not going to work. There's some either there's a property of XOR that I'm not thinking about, or there's some way of iterating over the indices while tracking the multipliers that are being applied to those indices, almost like some sort of sliding window, or almost like some current window of multipliers that add and remove based on the ranges of the queries. Like if a query goes in range and then goes out of range. I mean, in theory what? In theory, if I could do this, the queries simultaneously, if I didn't have to parse through every index in the query. If the query is 1,000 index and there's overlap between two queries, that if I can just do the overlap once rather than twice, or however many overlaps there are. Maybe that's just, yeah, how would I do that? I guess it boils down to the fact that queries queries can jump. Queries can jump. So not all the elements are modified in the same way. Can I handle the jumping somehow? Can I handle the jumping somehow? Either I handle it by some sort of compression or some sort of reduction of computation, like I'm thinking of trying to figure out the pattern here, or I handle it in some other kind of elegant way. I'm thinking, so I have to sort the queries, I'm almost certain. Queries have to be sorted. I don't think this is linear. I think this is n log n, because the optimization is the ranges on the queries, I think. How I handle the overlapping ranges. The overlapping ranges and also the, actually I don't even care about the overlapping ranges, it's just the gaps in the queries themselves. The fact that the indices can be incrementing by 2 or 3 or something besides 1. Because that makes the makes tracking the multipliers hard. Very, very hard. Is that right? It's like for every index, and then you have for every query at that index. For every index, and then for every query at the index. Ooh. So if a particular query goes from like 1 to, let's say 1 to 400 instead of 1 to 4, skipping it by 2, could I somehow have a bucket at say index 1 saying that this query is being applied to this index, and then push that kind of query to bucket 3, and then when it does bucket 3 it pushes it to bucket 5, and then when it does bucket 5 it pushes to bucket 7. I feel like that's still n squared because the query itself now becomes O of n, where n is the length of the query. You have n steps in the query, right? It doesn't just appear and then disappear from the, it can't just appear and disappear from the stacking multipliers at each index. It needs to appear, disappear n times. Unless I can somehow simplify the calculation that would occur, the resulting calculation. 0 to 2, skipping by ones. 0 to 2, skipping by ones. Yeah, if there was a way to simplify XOR calculations by the factorization of the values that are being exclusive ORed, I think I would have saw it at some point. Yeah, like if for instance like for 18.2 you can factor the 2 and get like 291 somehow. I think I would have learned that at some point. So I think that's going to be, I don't think I should pursue that train of thought. hard to tell exactly what the right train of thought is. Multiply by 3, multiply by 3. Multiply by 2, 2, and 2. Multiply by 2, multiply by 6, multiply by 2, multiply by 3, multiply by 1. Multiply by 6 here. Wait, what happened? 4 times... No, sorry. Multiply by 2, multiply by 3, so 4 times 6 is 18. 4 times 6 is 18. I wonder... I wonder... No, this doesn't... So certain ranges... 1, 1, multiply by 2, multiply by 6, multiply by 2, multiply by 3, multiply by 1. Is there a way to store that linearly? 2, 6, 2, 3, 1. Was it 2, 6? 2 times 2 is 4, 2 times 3 times 6 is 18, 1 times 2 is 2, 5 times 3, yeah. 2, 6, 2, 3, 1. If I start in a range, is there a fancy way? Fancy way to track this. 2 times 2 times 2 times 2. So when I see 0, 2, 1, 2, that indicates that there's like multiplications of 2 in those spots. And then I don't know if I should be filling it with 1s elsewhere. So 1, 3, 1, 3 for the other query, 1 through 4, skipping by 2s, filling with 3s. Or if I should just leave it blank. Times 2 times 6 times 2 times 3 times exclusive OR. The multipliers has a default value of 1. And then for every index, it needs to figure out what the correct index is, correct new multiplier is. 1 times 2 and somehow that times 3, and somehow that is then divided by 3. Is that right? Times 2 times 2 times 2. It feels like the underlying concept is something I should have done before, like overlapping meeting times where the meeting times are disjoint in some fashion rather than continuous. I guess I don't think I recall that. Overlapping kind of the scheduling type problems. Like give an array of meeting start and end times. Do some sort of calculation that generally is going to have like sorting and heaps involved, which is O of n log n. But here the meetings, which are the queries, are discontinuous, kind of discontinuous intervals, which makes it really hard, or which makes it not translatable for me to what I know anyways currently. Non-translatable, not translatable. I don't think I spelled latable wrong. I don't think I spelled it right. Translatable. That looks horrible as well. Whatever. So if I had, can I have a heap of queries and then I pull out the lowest query and then I push it back in the query if it's not done? I feel like that would be O of n though. I feel like that'd be O of n squared. Or that might be O of what would that be actually? Each query would need to be done n times. Yeah, I think that's O of n squared. Maybe O of n squared log n. I need to do each query kind of once or log n times. Can't do it n times. Was there some optimization of the query of the XOR calculation? Like A XOR B. Multiply times 2. Somehow bump it up to multiply times 6. Then go down to multiply by times 2. Ah. Wonder. Times 2 times 6 times 2 times 6 times 2. I wonder if there's a way for at any given window, I create a wave. I create a wave function. It's almost like a wave function. So for instance, if it was something where I'm multiplying by 2 every other one, so the query is like from index 0 to index n, multiply by 2 every other index, and let's say I have another query that multiplies by 3 but every third. It's almost like a wave, like you're combining amplitudes or product of waves or something. I wonder if there's a way for me to simplify this into a single wave function that I'm tracking. So like this obviously is 6 0 2 3 2 0 6 0 2 3 2 0 repeat. Is there a way to store this? So I would just need to store this part, right? Because then it repeats from there. So I see a query that modifies it by 2 every other. So then what I do is I create some sort of repetition of 2 0 as the multiplier. So the multiplier is an array of future repetitions of multiplying factors. And then I see another query that says multiply by 3 every third. So I need to modify the 20 to become the 6023 to 602320. And that becomes the new kind of multiplying factors. Do I need to? I probably don't want to be calculating that out each time. But maybe calculating out each time isn't that terrible. K goes 1 to n. That's actually pretty bad. Where k is the incrementing factor, incrementing value. If it goes 1 to n, then it's possible that I would need to track this out, this repetition out to n and modify it all the way to n, so that definitely doesn't help. So if I have disjoint meeting times, cannot just break the meeting times into, well, the other idea would be somehow for disjoint meeting times you create some sort of filler meeting time. So if you multiply by 3 at certain intervals, then you're dividing by 3 at other intervals. And multiplying by 3s at certain intervals, you're dividing by 3 at other intervals. Multiply by 3, divide by 3. Multiply by 3, divide by 3. Multiply by 3, divide by 3. Just makes, but unless I can somehow compact that, I don't want to do that repetition every single time for every query. So I need to compact it for all the queries some way. It can't be individual queries that cause that effect. It can't be tracking that effect individually. It needs to be some sort of meta query that combines those effects of those individual queries over that range. So I have some sort of multiplier or divider at every index. Multiplier or divider at every index. Multiply by 2. Divide by 2 at the same index. Multiply by 3, divide by 3 at the next index. And then have the wait turn skip over an index and then multiply by 3, divide by 3. That doesn't make sense. All right. Time to call it a night, I think.